Okay, so let's dive into one of the most incredible environmental turnaround stories you will ever hear. We're talking about how a dead, stinking pond was completely transformed into a thriving fishery. And this isn't just about one little lake in Montana. This could be a blueprint for reviving our planet's sickest waterways.
I mean, just look at this. It's night and day. On the left, you've got Fish Fry Lake in its original state, literally choked with this thick, nasty green carpet of algae. Then, on the right, that exact same body of water is crystal clear, vibrant, and just teeming with life. So the big question is, how on earth do you get from that before picture to the after? Well, that's the mystery we're going to unpack today.
And this quote right here, it just drives home how bad things really were. This wasn't just some slightly murky pond. They called it a pea soup green mosquito factory. The water was so toxic you wouldn't even let your dog near it. For all intents and purposes, this place was a complete dead zone.
So how does a place like that go from a total dead zone to a legendary fishery? Well, to get how incredible the revival of Fish Fry Lake really is, first we've got to understand what made it so sick to begin with.
Right, so before we can talk about the cure, we have to diagnose the illness. What's actually going on under the surface when a lake gets this sick? It's a huge question, because this isn't just happening in Montana. This is like a global epidemic, affecting thousands of lakes.
So, let's play doctor for a minute. If a lake is our patient, what's the diagnosis? Because figuring out that underlying condition is absolutely the first step before we can even dream about a cure.
The official scientific term for this sickness is eutrophication. But at its core, the problem is actually pretty simple. It's basically an overdose of nutrients, things like phosphorus and nitrogen, that often come from agricultural fertilizer runoff, and it all pours into the water. And just like fertilizer on your lawn, it makes something grow like crazy. But in this case, it's these massive choking blooms of algae.
Now, here's a really common misconception. You might hear the term nutrient-rich and think, hey, that sounds good, right? A productive ecosystem? But the reality is the total opposite. That thick blanket of algae on the surface, it eventually dies, sinks to the bottom, and starts to decompose. That whole process sucks up all the available oxygen in the water, creating what's called an anoxic or zero-oxygen dead zone that suffocates fish and pretty much all other aquatic life.
This is such a great way to think about it. The lake becomes like a clogged engine. You've got all this fuel, the nutrients, but it's not being used to power a healthy food web. No, it's just sitting there, short-circuiting the whole system and creating a huge cloud of smoke in the form of these algae blooms.
So, if the problem is a clogged engine, how do you fix it? Well, the solution they came up with at Fish Fry Lake was just brilliantly counterintuitive. They didn't try to remove the fuel. Instead, they figured out how to get the engine to burn it cleanly, turning that pollution into a thriving ecosystem. And this right here, this is the key to the whole operation. They installed these things called BioHaven Floating Islands. You can think of them as man-made, supercharged wetlands. What you're seeing here is the view from below. This dense, amazing network of roots and fibers that creates a huge surface area for beneficial microbes to grow. And it also provides critical shelter for fish.
And this slide really breaks down the genius of the system. See, instead of letting all those nutrients just fuel destructive algae blooms, they channeled that energy into a whole new food chain. The island's huge underwater surface area encourages the growth of biofilms. That's a living layer of algae, bacteria, and other microbes. This biofilm then becomes an all-you-can-eat buffet for tiny organisms. Those are eaten by small fish, which are then eaten by bigger game fish. They basically hacked the system to turn pollution directly into protein. It's incredible. So, did it work? Oh, you better believe it. In one study, the first-year yellow perch they caught in Fish Fry Lake were a staggering 135% larger than perch in a nearby control lake. That's not just survival, that's an ecosystem absolutely firing on all cylinders.
But the team at Fish Fry Lake, they didn't stop there. They went even deeper, tackling this invisible problem that was holding the lake back from its full potential. And this is where the science gets really cool.
So what's happening in those oxygen-free dead zones at the bottom of a sick lake? Well, it's a hidden problem. See, without oxygen, a totally different kind of microbial process takes over. And instead of healthy decomposition, the lake's sediment starts turning out huge amounts of methane, which is a really potent greenhouse gas.
It really all comes down to a battle between two different types of microbes. In the dark, oxygen-starved depths, you have the methanogens. Those are the methane makers. But if you can introduce oxygen, a whole different team shows up, the methanotrophs or the methane eaters. They literally consume methane as their food source.
And that is exactly what their RAM, or reduction of aquatic methane system, is designed to do. It's just an incredibly elegant solution. It uses a simple airlift to gently circulate the water, pulling that oxygen-starved water from the bottom, mixing it with oxygen at the surface, and then sending it right back down. This one simple action completely changes the microbial battlefield, tipping the scales in favor of the good guys, the methane eaters.
And the result? It was staggering. Within weeks of turning the system on, methane production in the lake dropped by up to 90%. 90%! The entire water column became fully oxygenated, from top to bottom, even under thick winter ice.
So, okay, Fish Fry Lake is an absolutely incredible success story. But is it just a one-off miracle, or is this a blueprint that we can actually use for other waterways around the world?
The tough reality is that this is a global problem. Eutrophication is happening everywhere, and it's driven by all sorts of things. It could be agricultural runoff like in Montana, or maybe it's stormwater washing off city streets, or even massive amounts of animal waste. Take Lake Champlain, for example, on the border of New York and Vermont. It's this massive, beautiful lake, and it's struggling with enormous phosphorus pollution, mostly from dairy farm runoff. It's the same core problem, just on a much, much larger scale. Or, look at Florida, where urban lakes like Morton and Hollingsworth are battling nutrient overload from city stormwater. And then you get these really unique cases, like Lake Augusta in Minnesota, which gets hit with over 7 tons of phosphorus-rich bird droppings every single year. The source has changed, but the sickness is the same. And this really brings us to the core lesson of this entire story. The solution wasn't to fight nature with a bunch of chemicals. It was to understand the natural system and just give it the tools it needed to heal itself. They worked with nature to reboot the entire ecosystem.
And that leaves us with a final, really powerful question. The story of Fish Fry Lake proves that this kind of transformation is actually possible. By working with nature's own processes, rebuilding food chains, rebalancing microbial ecosystems, we can turn our most polluted waters back into paradise. So the question is, what's stopping us from applying these lessons to the lakes and rivers in our own backyards?